Hi, and welcome to the Introduction to Machine Learning workshop. In this workshop, as the title suggests, we're going to be learning machine learning and touching up on artificial intelligence. For the prerequisites, I expect that you know Python. Any other languages such as JavaScript and C++ will be okay, but I would recommend knowing Python. It is required that you have an editor. I don't think Replit really works with TensorFlow and sklearn, so I think having something like Visual Studio Code installed on your local computer would be good. You may need algebra knowledge, as we're going to be also be touching on functions and finding the minimum and maximum value without calculus. So what is machine learning? I know that many people quote unquote know what machine learning is, but don't really acknowledge what it really is. Machine learning is the learning of a machine. When it gets input data, it finds patterns and analyzes the data. It goes under the category of artificial intelligence, which is the mimic of human behavior. Some topics we're going to be going over are how a neural network works, learn the process of coding our own model, and coding a neural network. I'll be showing you step by step. We're also going to be doing linear regression with both sklearn and TensorFlow. In addition, we're going to do some image classification with both raw images and regular images. By raw images, I'm talking about low resolution images, like 28 by 28 with grayscale. And by regular images, I'm talking about regular PNG or JPG files JPEG files that you can find basically anywhere on Google Images. Text classification, we're going to be learning how to categorize text by sentiment, like happy, sad. This is natural language processing. Throughout the whole video, you will be doing some exercise. I'll give you around 2 to 3 minutes for each one. I think it's really necessary that you do these exercises, as it will help your brain flow and remember the code better. How do neural networks work? First off, what is a neural network? A neural network are composed of layers with neurons. Neural networks are a method that machines use to perform specific calculations and get a clear output. So this is a diagram of a neural network. As you can see, these three are all layers, and these circles are considered neurons. So neurons are actually a thing that holds a value. So let's say I input the number 6. The neuron in the input layer would have a value of 6. The first layer is the input layer. Like I said, if we plug in 6 or both numbers 6 and 7, we will have 2 neurons in the first layer. The next few layers, or in this case just one layer, are the hidden layers. These hidden layers enhance the behavior of the neural network. The last layer gives the output value. As you can see from this diagram, you see that there's only one neuron at the end of this neural network. This signals that maybe this is a linear regression problem with 3 variables being inputted and one being outputted, one number being outputted. But usually in classification problems, we will have 2 or more, as each neuron represents a class. So next off, I'm going to be teaching you what kind of calculations that the neural network does, and how it gives such a nice clean output but with a high accuracy. This diagram shows a neural network that has an image as its input and outputs either a 1 or a 0. So how does an image transform into these neurons with values in the form of numbers? To investigate further, let's actually take a closer look at this image. So from this image, you can see that this is 28 by 28. Each pixel, there are like 20, since there are 28 by 8 by 28 pixels, there will be 784 pixels in total. Let's take the top left corner pixel. This is like white, so this would have a value of 0. On the other hand, for pure black pixels, that would have a value of 255. As you can guess, the darker pixels would have a value closer to 255, while lighter pixels would have a value closer to 0. Because computers don't like working with big numbers such as 255 and 200, we normalize the data. So what is normalization? Normalization is when we put the values in between 1 and 0. These are pretty small, and so the computer likes working like that. These 784 pixel values in between 1 and 0 are then put into this input layer. But what gives the values of all these neurons in the hidden layer? What kind of calculations does it do? So first, I will resize this back into the neural network. So each of the neurons in the input layer are assigned with a random weight. So let's call these weights weight 1, weight 2, weight 3, all the way to weight n. These weights are then multiplied by their corresponding neurons. So for example, we will multiply W1 by A1, W2 by A2, and all the way to Wn times An. These would take the value of H1. In addition, we would add or subtract by bytes. So to just process that again into text so that we can see it, visualize it. So W1, A1 plus all the way to Wn and then An. And then, like I said, we would add or subtract by a byte. So it's called the variable B. So this is what it looks. This is what one single neuron in the hidden layer would look like. Since the weights and biases will be random, at first the computer will plug in random values for the weights and biases. And this gives us really funny outputs for this. For example, we might get a 0.5 for 1 and maybe even like 0.3, like just a random number that I chose, 38 for the value of 0. Like, that doesn't make sense, right? Well, the computer is trained to know that 0 is the actual value, so it will try to fix these weights and biases. So it will try new ones, but they aren't completely random. Let me explain. So the computer actually graphs all of the possible weights and biases into a function. And they try to minimize this unclarity over here as an example over there into a function. So so this is a lot of information to cover. So let me give you a more simple neural network, just with the linear regression. So if I had some pixels like that, right? And let's say I was trying to predict a number. Let's say it was 6, 13. So 6 was the input and 13 is the output. So the neural network plugs in the 6, right? And they just plug in random numbers for the weight. So let's say they did weight equals 5 and bias is equal to 2. So this will give us 32 as the output, which doesn't seem close to 13. So using the graph and minimizing that unclarity and using calculus, it finds new values for these weights and biases. And soon enough, the computer will find that the weight might be 2 and the bias might equal 1. And then it plugs it in, 6, 13, it works. These will give us accurate values around W equals 2 and B equals 1. So this is how actually a neural network works. So we'll get started with actually learning what steps are needed to code it on our own model using a neural network, and we're going to jump right into the code. I know these lines are pretty uneven, but I tried my best. But these are the 6 steps to code your own model. So first we gotta import the modules, which are some that we're gonna use are like TensorFlow, definitely TensorFlow, sklearn, and they're like way more keras, and on and on and on. We can just if you know Python, you would just import it. Like for example, if I wanted to import TensorFlow, I could just do that. But make sure that for the pip, we have to install it using pip. So pip install TensorFlow. And let me just add a few more to this list. And then we also have pandas. I like to call it that. So import data. So for importing data, I usually find my datasets from Kaggle.com. It has like datasets, and it's made for machine learning purposes. So their datasets can come in form of like CSV files, which are like just files storing data, like columns and all. And we can just read this using pandas, and I'll actually show you an example once we get to the code. Some files require text files. Some may be in text files if we're building a recurrent neural network, which is when we have text and we're supposed to generate our own text. So we might actually have text files, but I don't think we'll use too many text files in this video. And then clean data. Remember about normalization? Yeah. So basically, your computer can't analyze just images and like just text. Like you gotta translate it into numbers. And make sure you normalize it. Normalization is extremely important. Also, then after we clean the data, we actually start creating the model. So we do this we just create layers that TensorFlow conveniently makes it very convenient for us to just create layers without having to do too much math. So one way we'll use the 𝗡𝗲𝘅𝘁𝗦𝗀 sequential model. And then we'll also fit the inputs with the outputs for the training. Fit the inputs and outputs. So that's how we create the model. We compile the model. So once we have the model variable in the form of the 𝗡𝗲𝘅𝘁𝗦𝗀 sequential model that we created, we can do model.compile. And then, so in these are going to be both optimizers and the loss function. So loss function kind of finds like, what is wrong with it, and then like how we can make those weights and biases better, like we said. And there are many different functions for the optimizers and loss functions, and each function depends like there's no really best answer to what the best loss function is or what the best optimizer is. It just depends for each situation. And then we test it. So we test it using validation data. So we can actually split our training data with half training data and half training data and half testing data. Testing data will allow us to see the accuracy of our model. And that's pretty much it to coding neural networks, what it really is. And thank you for hanging on with me for 10 minutes. And then we're gonna jump right into the code. So see you at Visual Studio Code. I have created my files and I currently have my data sets ready. We're not going to use a data set for the regression bot for TensorFlow. Instead, we're just going to use data from a NumPy array. So first off, you want to download all these modules. And once you did so, let's get started. So first, we want to import TensorFlow, which if you don't do it, it's going to make a big error. And then from TensorFlow, you also want to import 𝗡𝗲𝘅𝘁𝗦𝘁𝗲𝗽, which is going to allow us to create our model. In addition, we also want NumPy as it'll help us with sorting our arrays. So I already got the points ready. Over here, I plotted the points on decimals, and these are the points we're going to feed into the computer. And we're going to make the computer predict what the y value will be when x is equal to 5. So in that, I already got the code ready for that. You can take the time to pause and copy this. Once you Once you copied it, we're gonna create our model straight away. Equals 𝗡𝗲𝘅𝗁𝗁. It's learn. So the thing is, let's say you know how to do the alphabet. You know how to A B C D E F G H I J K L M N O P. But let's say you try saying the alphabet backwards, which isn't so you know nice. I mean, let me try it. Z Y X W. Yeah, it's harder than just saying A B C D, right? It's the same for this one as well. You're going sequentially instead of just random order. So after that, we add a parentheses, and you need a bracket inside of these parentheses. And then we do we're only gonna have one layer, like I showed you in the neural network demonstration that I did. And we create a layer by doing this. So carousel layer settings, and this layer is only gonna have one neuron, and the input shape is going to be one, because we're only going to have one number plugging it into our model. After that, we're going to compile our model. So we're going to compile it. Optimizer is SGD. I won't go too much in detail about what this optimizer function does and its math behind it, but for both the optimizers and loss functions, if you're curious, you can always search up on Google. So loss equals mean squared error. So that's that. And then we fit this into X and Y. So, and then we also need the amount of epochs. So epochs, let's just say 10 for now, and let's see what happens. And then we're gonna do model.predict. We want to print that result actually, so print model.predict, and then 5. So let's see what happens. So Python, so we gotta save that first. Python regression. So it gives a funny result of around 7, right? Which is not really what we're expecting. We're expecting more around 9, correct? But it's getting all the way down there, which doesn't make any sense. So why can this be? I mean, what happened? Like, I don't really. You might. So the thing is, the amount of epochs are too low. If you can see these loss here, it's very high. You want it to be low, and we do this by. I mean, if not too many epochs is not good, but too low is not good either. So you want just the right amount. Let's say we do 100. Save Python regression. Py. So it's gonna train in just a moment. So as you can see, it gives a better result than last time, which, I mean, based on, you can see it's around 9.35, right? Which gives a good result. So you always want to see if the result is reasonable, and if it's not, try to adjust the number of epochs. So that's the basic linear regression for TensorFlow. For sklearn, however, it's a bit different. So I'm gonna pause right now, and so now we're gonna do regression with sklearn. So first off, we want to import our data. I found my data on insurance.csv. You can find the link for Kaggle in the description of this video. First off, we're going to import pandas as PD, and then we're also going to import numpy as well. So first off, we're going to read our data. We do this by using this function read CSV, and then we're going to get the file name, which is insurance.csv. So this just reads all the columns and rows of the data in here. Next, we're going to we're also going to use smoker, if there's smoke or not. But remember, the computer does not like working with text, so we're going to convert it no to 0 and yes to 1. we do this by using the replace function. So for example, data smoker equals data smoker dot replace. Remember to put the braces inside these parentheses. Yes, and then we're gonna set this to 1. So this function is just replacing all the yeses in the smoker column to 1. We can copy and paste this code, and then we can replace the no with the value of 0. So now we got that done. So we want to create our inputs now. So our input is we're gonna set it to variable x, and we're gonna include every single column except for the columns that we're gonna list right now, which is gonna be their sex, their region in which they live in, and charges, which we're gonna set for the output value. So that's that, and then we have y equaling to the data, the column of charges, which shows the amount of money that has been charged. So now we're gonna create our model. So we're gonna import the decision tree regressor. We're gonna create our model, set it to decision tree regressor, and random state. So setting random state equal to a value, make sure that the outputs are consistent. And then we're gonna fit the x's with the y's. And then we're gonna create a numpy array. So array 1 equals np.array. So we know that since we're dropping these columns, the first one would be the age. So we would have the age, which we're gonna plug in 21 for. In addition, their BMI, which I'm gonna set 25. And then the next one is going to be, I believe, yes, smoker or children. Yes. So it's gonna have 2 children. Let's say he has 2 children, and it's gonna be he. So we're gonna set that equal to 1. And then all we do is now predict. So we make the model predict, and then so we put 2 brackets, 1 bracket, and then another bracket inside. And actually, since we just have the array, we're just gonna do array 1. And let's see what value we get when we save this. So Python regressionbot.py. So it looks like we can't subscript. So instead of just doing this numpy array, I'm gonna just plug in the array that we originally had, which I believe was 25, 21, number of children, and 1. So yep, and then we're gonna do Python regression bot.py to see what other errors. I think we might have to put the spaces here. Let me save that. Or I don't think I saved it last time. And then Python. So we actually got our value, which was 14,571, around there. And we can see that that's pretty accurate, seeing our data we have. So, yep, that's that. And then we're gonna move on to image classification with raw data. So right now we're gonna classify images, clothing images, to their categories such as t-shirts, trousers, dresses, coats, pullovers, etc. So we're gonna be using a data set from MNIST, which has 28 by 28 grayscale images. So they're kind of raw instead of those regular images I was talking about. So, but let's get started. So we will first import TensorFlow, and then we will also import NumPy as NP. Then we're gonna load our data. So in order to load our data, we have to do dataset.fashion -t, and then we would load the data. So we would do train images, train labels, and then train test images, and test labels is equal to data.load data. So what this does is it splits all the data into the either testing or for training. So remember that the images, each pixel has is in the range of 0 to 255. We want to make sure that we normalize it. So remember we have to divide by 255. Same for the test images as well, because they're just literally the same images as the training ones. And then what we do is, after normalizing our data, we can actually get started with our model. So model equals carousel sequential. And then we will have to flatten out all those pixels into the neuron for the first layer. So we would do tf.carousel.layers.dense. tf.flatten input shape is equal to 28, 28. Because remember, these images are 28 by 28. And then what we would do is tf.carousel layers.dense 128, because we're going to put 128 neurons in that layer. And we're going to set the activation equal to rate. So what ReLU does is, for every positive number, it keeps it, but for everything, I believe less than 2, I kind of forgot, but it'll just throw those away. I'll check in later. So that's the ReLU. And then we finally have dense 10 as their 10 classes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's that. And then we do model.compile. Oh, so this part I actually copied it because I knew that I was going to make a typo. So there it is. So you can take the time to pause and copy that. Next, we're going to have to fit for our training. So we have to do train images. Okay, train images and fit that with the train labels. And we're going to have 10 epochs, because these epochs might take some time. After using 10 epochs, we're gonna actually start predicting, because we're now done with our whole model. So we're gonna do print. We're gonna print the result model.predict. Model.predict. Test images 0 dot reshape 128. So what we're doing here is we're taking a test image, and then the first test image, and actually we're reshaping it to this because we know that there's one image and it's 28 by 28, and since it's grayscale, we don't really add any numbers over here. So let's try to run our code. So we got first save Python image class.py. TF. Oh, so remember, we have to actually put commas over here because it is, after all, an array. And we just have to wait. Okay. Oh, oops, I forgot. TF. Is there any other silly mistakes that I might have made? I don't think so. Let's hope that doesn't make another error. So basically, as you can see, it's kind of like a low accuracy for now, but it's gonna keep improving. You can see that these epochs actually took longer than the linear regression ones. They took like 2 milliseconds, and that's because we're actually loading in images, and it's gonna take a long time to find those weights and biases. So we can see that the loss is slowly decreasing while the accuracy is actually slowly increasing. And for our result, we won't actually get a clear result. Like it's not gonna say t-shirt or anything like that. It'll actually give us the values of the neurons for the categories. So we can see that this one has the highest one, so we would categorize it into ankle boot, which is actually what it really is. So yeah, that's it for the raw images. Let's move on to the regular images now. Okay, this is the code for classifying images. So first, we download all our models, image data generator and the image. So for the training images, this function actually returns all the transformed images. So first off, we're actually dividing each pixel value by 255. This, what it does is it gives for every single, we rotate it by 2, we rotate it by 3, we rotate it by 4, and all that. We are also multiplying the width in the range of 0.8 to 1.2. Same for the height as well. So over here, what we're doing is so in the archives section, this is our data set. So I'm trying to classify weather. So if you can see frost, it'll look like this, as you can see. But yeah, overall in general, we're just actually taking advantage that each image is inside the directory that they're supposed to be in. So if we go back, so this code is just basically telling, okay, from these images that you got from here, to return. So for example, you can return sandstorm on the image from sandstorm and label it sandstorm automatically. This will just return a tf.data.datasets object, which makes it convenient for us to just plug it into the model. So here is our model. We have around 4 convolutional layers. So each of these convolutional layers actually enhances the image. So what it does is it multiplies by some number, like weights that we talked about, and then it creates this kind of like grayscale image. And what it does is it tries to classify from there. So yeah, pooling also is the process of multiplying the numbers as well, but this time we're actually shrinking the image by 1/4. And what pooling does is essentially it enhances the image so the computer can read it better. Then we flatten all those neurons, which are all pixels, into the first input layer. We drop out some of the neurons that are kind of unnecessary. And then we have a ReLU with another layer with the activation of ReLU. And then we finally get 3 for the softmax. Actually, this should be around 12, I think. Yeah, it's supposed to actually be 12. Sorry about that. And then what we do is compile the model. So we can compile it by loss, categorical cost, entropy, and these are all just this is mostly used for image classification. And then what we do is remember how these training generators are. So if we have an image and it just labels it automatically. So we don't have to put any special things. And then we have epochs, steps per epoch. Sorry about this. I don't know why that's there. And then we have our classifying image. So basically all this does is once you plug in an image into the image path, it just results in the image. And this computer program actually takes a long time, and I unfortunately cannot do it with the time given. So while you're eating lunch or dinner or breakfast, whatever you're doing, make sure to run this code. This will take around maybe from 25 to 50 minutes. So tell me how it goes. So for the final project, we're gonna do text classification project, and we're gonna detect if a message is spam or ham. So ham would just be not spam, it's just a fun way that they sort it out. So this is a link to the dataset. You can download it and put it into the directory that you are currently working on. So if we get started, we start with the usual modules. So and then we also import NumPy and P. And then from TensorFlow, import keras. This time we'll also use the tokenizer and the path sequences. So we can import this by doing from TensorFlow.keras.preprocessing.text import tokenizer. From TensorFlow.keras.preprocessing.sequence import path sequence. So what the tokener essentially does is, remember how the computer cannot recognize text, remember, it only works with numbers. So what the tokenizer does is for every single word, it assigns a number to it, an integer. And then for the path sequences, we're making sure that each text, message, or text has the same amount of words. So first off, we need the data. So we can retrieve the data by first importing pandas as PD. Sorry about that. And then what we do is we, get the data set. So we'll call this data set equals pd.read csv spam data.csv. You should probably rename your CSV file because it's going to have really funky numbers. So just rename it to something simple that you would remember. So what this does is just essentially reads this CSV file over here. Next, what we're going to do is, since each of these are all ham, spam, we don't want those. Instead, we want to just replace them with 0 or 1. So what we do is we go over here and then we say spam, dataset category becomes dataset category replace ham as. So what it's doing is for every single ham found in the category column, it just replaces it with 0. And next, what we do is we also replace the spams with the 1. So we'll just copy and paste this. And then we replace the ham with the spam and put it to 1. So we'll first set these equal to the array of messages. So that'll be dataset category. So this is category. So this function over here returns an array of numbers with all the messages under this. And for the message, spam message, it returns the array of all the numbers under this column. So if we do that, we also need to split our training sentences with our testing sentences so that we can evaluate our model later. So we can see that this has around 5,000 rows. If you scroll down a little bit more than that. So we will split the training sentences into the first 5,000, while the others are going to be tested. So for here, we're going to do is training sentences equals message from 0 to 5,000. Training labels is category 0 to 5,000. And then we just do these for the testing sentences and testing labels as well. Message 5,000 and testing labels category 5,000. Over there, you can see that we just split it up. Now it's time to use our tokenizer. So our tokenizer, like I said, will assign every single word with a value. And so since we input it over here, we can say the tokenizer value would be equal to tokenizer. And then we're going to assign the number of words to 17,500. So the reason for this is we need to restrict the number of words because there's like a lot of words here, and it's going to be hard to learn very quickly. So what it's going to do is going to find the 17,500 most common words, and then it'll tokenize those. So we're going to use the OOV token as well. So it removes any other special characters and etc. So we just assigned it, but we have to say which text and sequences we wanted to assign it to. So in this case, it's the training sentences. So next, we actually want to put these training sentences into sequences. So if I have dog is better than cat, for example, if I have that, let's say dog will equal 2, is 1, better is 3, then is 5, and cat equals 4. What it's going to do is it's going to make it to 2, 1, 3, 5, 4, like that. So let's see. So we can do training sentence sequences equals tokenizer.text. Remember this S over here, to sequences with the training sentences. And then next, we do training sequences. Now that we have our training sequences, we also need to pad it. So in order to pad it, we need to make the same amount of length. What this does is just adds extra zeros to the begin. And just a note, this is actually mostly copied from the visual TensorFlow videos that I found on YouTube. I'll link them below because they will give you more information about this because they're the developers. So training sequences is that pad train is equal to pad sequences, training sequences. So it's just padding these sequences over here, and we're gonna make the length of it equal to 100. And padding equals post. We can do the same for the testing sequences as well. So testing sequences equals tokenizer.text to sequences texting. Testing sentences and pad test is equal to pad sequences testing sequences. Again, we're going to make the length 100 and padding is post. We set that to that. So we got to put these into NumPy arrays, or else it'll give us the wrong format. So what we're going to do is we're going to do pad train equals np.array pad train. So we're going to put this into to the form of a NumPy array, and then test empty the array test. We're gonna do this. We're gonna put the labels into actually NP arrays also. So training labels equals np.array. Training labels, testing labels similarly np.array testing labels. So now that we put these into NumPy arrays, we can actually start creating our model. So model equals 𝗡𝗲𝘅𝗁𝗁 brackets, and then we do 𝗡𝗲𝘅𝗁𝗁.embedding 70,500 dimension of 8 and input length equals 100 because we added it to 100 length. For those wondering what embedding is doing, let me give you a quick look on it. So over here we have spam or ham, and each word is going to be classified as a vector. So let's say free, you see those spam messages of get your free membership today using your credit card. So so free may be like over on this side because those are mostly in those spam messages instead of this. For more of those like kind, maybe it's like over here. So basically it just sorts words into these vectors and where it's heading. So back here, we're going to also create the dense layers as well. Oh, one thing. 𝗡𝗲𝘅𝗁𝗁.global average pooling 1D. So this is just like basically like the embedding layer, but kind of, I don't know, I think that it enhances it. Yeah. So 𝗡𝗲, and then I forgot to put the comments over there. So the global average pooling ID, and then we have 𝗡𝗲𝘅𝗁𝗁.dense 24 activation equals ReLU. So remember, ReLU is like the ReLU was the one. I think it was the one about the getting rid of some numbers and just keeping the numbers that as they are for some other numbers. So it's like a piecewise function. It removes some numbers and it keeps some numbers as they are. So for numbers that are greater than 0, I believe, it keeps it, while the one on the left side, it just puts it in the trash. So yeah. And then we also have another layer, 𝗡𝗲𝘅𝗁𝗁.dense, and then 1 activation equals sigmoid. So we only have 1 instead of 2 because the reason being is we only want a number from 0 to 1, correct? Because we want to see how close it is to spam, which is 1, or how close it is to ham, which is 0. So we'll just put 1 there, over there, and then we have to compile the model. So we do model.compile. I'm going to make the optimizer Atom, and loss will be the mean squared error. We're going to also fit with the x's and the y's. In this case, the x would be the pattern, and the y would be training labels. I'm going to set the epochs to 30 because I think that's a good amount for text. Okay, so now all we have to do is just predict. So let's say I have the testing. Let's make a testing sentence equal, I don't know. Let's make something really sound like spam. So let's say get your free membership at, I don't know. Let's think of a random acronym, LPOT, by calling this number and giving your credit card info below. I don't know. That sounds like a real spam to me. And then we do sequences equal tokenizer dot text to sequences, because remember we also have to tokenize it and pad it to predict it as well. Text to sequences, testing sentence. And then we also have padded sequence equals pad sequences. We're gonna also set the length equal to 100 because it needs to have the same shape. So post, padding equals post, and then finally we just want to print the padded sequence, the prediction of the padded sequence. So let's see how this works out. We first have to save it. Python. Where is it? Okay. Python mlp bot.py. Oh, whoops! I forgot the commas again, which is not a good habit, but I'm trying to fix it. Save Python mlp. So for some reason, I think the epochs are going to be fast, around 3 milliseconds for this one. Uh-oh. You cannot import name pad sequence. Oh, okay. So pad sequences, right? Pad sequences. I think I made a few other typos as well. Let's see. Oh, okay. Yep, I bet you already caught this too. I don't know. I don't know why spam was in my mind for that one. Please word. Okay. OV. Oh, OV token is supposed to, yeah. Okay. Yeah, I made a lot of typos. Let's hope this actually works. Oh my goodness. Okay. Text sequences. What is up with typos today? I bet there's another one. Oh, it starts working again. Okay. So this shouldn't take too long. As you can see, the loss is decreasing at a pretty good rate, I would say. It's pretty low. Seems like it's not taking such a long time. And we get a pretty 0.7, which is actually closer to spam. But the reason being for why it's not completely 0.99 might be because we have less, like not enough epochs, or we might just not put that much words, because each one kind of has a lot of words for the spams, right? We see urgent, yeah. So, I mean, I think it's pretty close though, but it's good enough. So, yeah, that's it to natural language processing. I hope you enjoyed the video, and I hope to see you again. Bye.